Hello grade 10s, and welcome to this lesson on revision of linear equations. Equations have many practical uses in our everyday lives. Solving equations can help find the height of a bridge or the minimum mark needed on your final exam so you can pass the year. Do you remember what a linear equation is? In a linear equation, the highest power of the variable is 1. Let me show you what I mean. 3x minus 4 equals 17, and 2y plus 3 equals negative 5 are examples of linear equations. If you look at x and y, you will see there are no exponents written. But remember, if there are no exponents, this means there is actually an exponent of 1. Balancing an equation is similar to balancing a scale. To keep the balance of the scale, you have to add equal weights to both pans. In an equation, what you do to one side, you must do to the other side to keep the equation balanced at all times. If the question says, solve for x, it means you need to find the value of x that makes the equation true. You need to manipulate the equation to get the x alone on one side of the equal sign. Now for the first example. Solve for x if 3x minus 4 equals 17. First, we must get the term with the variable by itself. In this case, the 3x. To do this, we have to add 4 to both sides. On the left-hand side, we are left with 3x, and on the right, we get 17 plus 4. 17 plus 4 equals 21 on the right-hand side. Now we need to divide both sides by 3 to get the x by itself. So 3 divided by 3 gives us x on the left-hand side, and 21 divided by 3 equals 7. So this tells us that 7 is the solution that makes the equation work. If you substitute the 7 back into the original equation, you can check your answer. Substitute x equals 7 into the left-hand side of the equation in brackets, and you get 3 times 7, which is 21. Minus 4, so you get an answer of 17, and this equals the right-hand side. So x equals 7 is the right answer. Remember, the check just confirms that our answer is correct. We could have done example 1 in a quicker way. Let me show you how. When 4 is added to the negative 4 on the left, both of them would disappear. To save time, you could simply drop the minus 4 on the left and add 4 on the right. This looks like you are moving the 4 to the right-hand side of the equation by changing its operation. To get rid of the 3, you would usually divide both sides by 3. To save time, you could drop the 3 on the left and divide by 3 on the right. It looks like the 3 is moving from one side to the other and changing its operation from multiply to divide. The answer is 7. Let's use this shorter method in the next example. Solve for y. If 8 times y minus 5 minus 2 times y minus 3 is equal to 10 minus 4 times 2y minus 3. First, remove the brackets by using distributive law. You should get 8y minus 40. Minus 2y plus 6 equals 10 minus 8y plus 12. Then add the like terms on both sides of the equal sign. This is 6y minus 34 is equals to 22 minus 8y. Now collect all the terms with y on the left-hand side and move your numbers to the right-hand side. Remember to change the operation of the terms you move across the equal sign. On the left, you have 14y, and on the right, you end up with 56. because 14 is multiplying the variable y. When it is moved to the other side, the operation changes to divide. 56 divided by 14 is 4. Therefore, y is equal to 4. I hope that by now you recall simple linear equations. Let's look at an example that involves fractions. Remember, to solve an equation with a fraction, first change it to an equation without a fraction by finding the lowest common denominator, or LCD.
Take a look at this example. Solve for x if 3 divided by 2x minus a quarter is equal to 6 divided by x. Now, how should we solve this equation? What can you think of doing? If you thought of finding a common denominator to multiply each of these terms by, then you are quite correct. Now let's have a look at these denominators again. We have 2x, 4, and x. We can find a common multiple by multiplying out the denominators. 2x multiplied by 4 multiplied by x gives me 8x squared. This number is a common multiple. But remember, we need to find the lowest, smallest common multiple. Do you know why we have to find the lowest common multiple? The reason is very simple. We try to keep our calculation as easy and simple as possible. To find the lowest common multiple of these numbers, we must factorize them. So, 2x is equal to 2 times x. 4 is equal to 2 times 2. And if we go back to our question, we see that x is already in its simplest form. So we can write x is equal to x. Now, what is the lowest common multiple of these numbers? Remember two facts about the lowest common multiple. 1, it is the smallest number into which all these numbers will divide. And 2, it includes all the factors of all the numbers. So now let's create that number. LCM. For 2x to divide into the multiple, it must contain a 2 and an x. So let's write 2 multiplied by x. For 4 to divide into the multiple, it must contain 2 and a 2. Now if you look, there's already 1 2 here, which means I need to multiply by another 2. For x to be part of the multiple must contain an x. But if you look, the x is already here, so we don't need to write another one. This means that our LCM can now be written as 2 times x times 2, which is in fact 4x. Right, what is the next step? How do we use the LCM to solve the equation? To simplify this equation, we must multiply every term by the LCM. Remember, we are working with fractions, so we need to write the LCM as a fraction. So we get 3 divided by 2x multiplied by 4x over 1, which is the LCM, minus a quarter multiplied by 4x over 1 is equal to 6 divided by x multiplied by 4x over 1. Now, we need to cancel out terms. 2 goes into 2 once. 4 divides by 2 twice. The x's divide into each other once. 4 goes into 4 once. 4 goes into 4 once. Here, the x's divide into each other and we end up with 1. Right, let's see what we are left with. 3 multiplied by 2 minus x is equal to 6 times 4. Let's multiply out our numbers. 3 times 2 is 6 minus x is equal to 6 times 4, which is 24. Now we want to solve for x. I'm going to subtract 6 from both sides of the equation. I get 6 minus x is equal to 24 minus 6. We're left with minus x is equal to 18. But remember, we are solving for positive x, which means that I need to divide both sides by negative 1. I get x is equal to negative 18. Let's check our answer. Now, if we substitute negative 18 into our original equation, our answer will be correct if the left-hand side is equal to the right-hand side. Let's check our answer. The left-hand side is equal to 3 divided by 2x minus a quarter. Let's substitute negative 18 for x. We get 3 divided by 2 times negative 18 gives me negative 36 minus a quarter. Now, do you see that we can simplify this fraction further? 3 goes into 3 once, 3 goes into 36 12 times. So we are left with 1 divided by negative 12 minus a quarter. Now we are subtracting fractions. Do you remember what we must do when we are adding and subtracting fractions? Yes, we need to find the lowest common denominator. Now if you look at 12 and 4, we've got to think, what is the lowest common denominator that 12 and 4 can both go into? We know that the answer is 12, so we can write negative 1/12 minus. Now, we need to convert the 4 to a 12, which means I must multiply by 3. But remember, whatever we do to the denominator, we must also do to the numerator, which means I must also multiply by 3. So in effect, I am multiplying by 3 divided by 3. I get 3 divided by 4 times 3 is 12. Now, we have the same denominators, which means that we can subtract the fractions. I get minus 4 over 12. Now, if we look carefully, we can see that this fraction can still be simplified further. 4 divides into 4 once, 4 divides into 12 3 times. So I am left with negative 1/3. Now let's simplify the right-hand side. We know that x is negative 18, so let's substitute. We got 6 divided by negative 18. This is one fraction, so all we have to do is simplify this fraction. 6 divides into 6 once, 6 goes into 18 3 times. I am left with negative 1/3. Now, because the left-hand side is equal to the right-hand side, we know that our answer, x equals to negative 18, satisfies this equation. In other words, our calculations were correct. Now, it is always a good idea to check your answer just to make sure that we didn't make any mistakes. Now, there's just one more concept that we have to deal with when working with fractions with unknowns in the denominator. Let's have a look at the original question. Consider the fraction 6 divided by x. For what values of x is this fraction defined? Think about it. Can x be any value? Do you remember that when we are working with fractions, there is a restriction on the denominator? The denominator cannot be equal to 0. So, 6 divided by 0 would make this fraction undefined. So the restriction here is x is not equal to 0. Now in this fraction, the same is true. If x were equal to 0, 2 times 0 would be 0. 3 divided by 0 would make this fraction undefined. So the restriction is still true. X is not equal to 0. When you solve an equation, always remember that if the fraction contains an unknown in the denominator, always check that your denominator is defined.
Thanks for that lesson, Omashni. That's it for now, grade 10s. Remember to look at the tasks for this section in the equations and inequalities task video. You will also be able to learn more about equations on our website, www.mindset.co.za/learn. Goodbye.